Okay, hi guys. This is exercise 5.4 from Signal Conversions. So this is all about sampling frequency. It's Nyquist, it's called. As long as you sample at twice the highest audio, you're okay. Nyquist theory, the theorem. Twice the highest audio. So what's that? 8, 10 kilohertz. That is 13.6 kilohertz and 16.4. Okay, so as long as you sample at twice the highest audio, or even higher, the higher the better, but at least twice the highest audio. That's the minimum sampling frequency. Okay, we looked at this before in exercise 5.1, resolution. So we're going to use the old equations. So the resolution equals the input voltage range divided by 2 to the n. Okay, so what's the input voltage range? 5 volts. It's 24 bits, so it's 2 to the 24 equals 0.298 microvolts. That's your answer for that. Quantization error, that's basically half of the resolution. So it's dead easy. I believe that's on your data sheet. Half resolution. That's going to be resolution divided by 2. In this particular case, that equals 0.149 microvolts. I'm just going to check your data sheet. It should be in here. Let's just check your data sheet, see if that is on there or not. So we have, that's data rates. There you go. Data rate is twice the bandwidth. No, that's not the one, is it actually? That's about data rate. So no, you don't get that one. You get your resolution one. Yes, you don't get your quantized error one. So quantized error is basically your half your resolution. So it's like your smallest voltage range, but obviously it could be plus or minus. So that's why it's half the resolution. I hope that makes sense. Back onto this one. Where are we gone? Oh, back onto this one, sorry. Okay. So that's that. Right, let's have a little look at this one now. This one is using that other equation that I said. So we've got a recording studio, 74 minutes. That's going to have to be converted to second later. 16 bits, sampling frequency we've been given. How much data is stored on the disk? So first of all, we need to work out your bit rate. See, what's your bit rate? Your bit rate is a sampling frequency. Sample frequency multiplied by number of bits. Okay, number of bits per sample. So in this particular case, it's 44.1 times 10 to the 3. That's not very good equals. Multiplied by 16. Okay, I'll convert back into into kilo. So 705.6 kilobits. Yep, per second. Remember, we can write seconds like that, seconds to the -1. So the sampling frequency, if you multiply it by the number of bits per sample, you end up with the kilobits per second. That's your bit rate. So that's how many bits per second. The 74 minutes. So how would we work out the file size? See how many of those will fit into it. So it's going to be 705.6 times 10 to the 3. Because I'm converting it back to bits. It's got to be bits. Multiplied by the number of seconds. Okay, so because it's per second, to get rid of the per second, we multiply by seconds. So how many seconds? There's going to be 74 times 60 seconds. That's how many seconds we've got. So essentially, to get rid of the per, this bit here, the per second, we multiply by seconds. That's how you get your file size. That should equal 3133, and it's in mega. Convert it to mega. Calculator will do that, megabytes or megabits. That's your file size. So it's a 3,133 megabytes. Just going to double check. I think that bitrate one is on the data sheet, as we just had a look. So you've got maximum data rate is twice the bandwidth. That's what I've just said about your data rate. That's about channel bandwidth. The bitrate one isn't on there, is it? No, it's not. So your bitrate is actually not on there. But you do have, obviously, the other ones on there as well. So that's a bit annoying, but there you go. But I hope that makes sense anyway, how you would do that. Yeah. So you need to go convert to bits per second. How would you do the bits per second? You've already got the per second bit there. That's kilohertz. That's in hertz. And you've obviously got 16-bit there. So that's your first bit. And then obviously you times it by the amount of seconds you've got. Okay, so as I say, it is a bit of a tricky one, that one. But hopefully it made sense how I explained it. You need to know your maths. And again, that one is on the data sheet there. Okay. Right, so we'll leave that one there. That is all of signal conversion done.